Until only about 2 years ago, astronomers thought that the first galaxies developed within massive halos of dark matter. However, a recently discovered galaxy, estimated to be around 13 billion years old, unexpectedly formed much earlier than this process should have allowed. Yes, the James Webb Space Telescope has discovered an enormous galaxy in the early universe that defies the standard model of cosmology. And it's not me saying it, but the scientists associated with the discovery. Welcome to Territory. This is your space. The galaxy, known as ZFUDS 7329, contains more stars than the Milky Way, despite forming just 800 million years after the universe began. That shouldn't be possible. Galaxies like the Milky Way are believed to take about 1 to 2 billion years to form. So, does this suggest that this galaxy formed without the influence of dark matter, contrary to the standard model of galaxy formation? This would also hint towards the existence of other such galaxies, right? Scientists are uncertain how galaxies like these could have formed so early in the universe's history. The exact process behind this remains unclear. It is a surprise, much like other massive early galaxies discovered by the JWST. ZFUDS 7329 challenges our understanding of the formation of the first matter in the universe and possibly even the standard model of cosmology itself. We know light travels at a fixed speed through the vacuum of space, so the deeper we look into the universe, the more remote light we intercept and the further back in time we see. This is what enabled the scientists to spot ZFUDS 7329 roughly 11.5 billion years in the past using the Webb telescope. By studying the spectra of light coming from the stars of this extremely distant galaxy, they found that the stars were born 1.5 billion years prior to that observation, or roughly 13 billion years ago. Having these extremely massive galaxies so early in the universe is posing significant challenges to our standard model of cosmology, study co-author Claudia Lagos said in a statement. This is because massive dark matter structures, which are thought to be necessary components for holding early galaxies together, did not yet have time to form this early in the universe, Lagos added. Astronomers aren't certain when the very first globules of stars began to clump into the galaxies we see today, but cosmologists previously estimated that the process began slowly within the first few hundred million years after the Big Bang. But observations with the James Webb Telescope have found galaxies that existed only 290 million years after the Big Bang, and data indicates the existence of galaxies in the early universe that are even older. The cherry on top is that some of these galaxies are fully formed with active supermassive black holes at their heart. The standard model cannot explain this, unless you tweak a few things, of course, like maybe stars formed much faster in the early universe than previously thought. It might even be that the star-turned-black hole scenario is not the only way black holes form, because otherwise our cosmological model struggles to explain these giants madly devouring matter within only 1 billion years of the Big Bang. The conundrums keep piling on, and for the first time, our models are showing flaws that cannot be fixed with simple adjustments. If the James Webb Telescope is discovering galaxies that are only a couple of 100 million years younger than the Big Bang, what about stars that inhabit those galaxies? How old are they? A team of astronomers set out to find the answer in 2022 when they spotted 3 massive objects that are very, very old. So they zeroed in on them and found that these objects were emitting light from stars that appear to be shockingly old. The galaxies themselves seem to have formed 700 million years after the Big Bang and look nothing like their counterparts in the modern universe. While 700 million years might appear as an exceptionally lengthy period following the Big Bang, considering that the universe is 13.8 billion years old, these little red dots existed when the universe was just 5% of its present age. But check this out. When scientists studied the intensity of different wavelengths of light coming from the little red dots, they found something startling. The stars show signs that they are hundreds of millions of years old, and according to our theories, they are not expected to inhabit the universe so early on. So what is going on? To make matters more complicated, the researchers also identified signs of supermassive black holes in the areas surrounding these small red dots, which are thousands of times bigger than Sagittarius A, the supermassive black hole at the center of our galaxy. An in-depth analysis of these objects' light spectra confirmed that they are galaxies from the very dawn of time. This revealed that the impressive light output of the red dots is powered by overgrown supermassive black holes and unexpectedly old stars. This implies that these galaxies are either surprisingly old and more massive than the Milky Way, having formed much earlier than models predict, or they have normal amounts of mass but unusually large black holes. What also sets these primordial galaxies apart from the rest is that despite harboring nearly as many stars as the Milky Way, they appear significantly smaller. To provide perspective, if the Milky Way was scaled down to the size of one of these red dot galaxies, the closest star to the Sun, Proxima Centauri, which is 4.2 light-years away, would reside within our solar system. In fact, the distance between Earth and Sagittarius A would shrink from 26,000 light-years to just 26 light-years, making it visible in the night sky from Earth. "It's very confusing," said Joel Leger, an astrophysicist at Penn State, and one of the scientists behind this discovery. "You can make this uncomfortably fit in our current model of the universe, but only if we evoke some exotic, insanely rapid formation at the beginning of time." Meanwhile, the lead scientist of this discovery, Bingji Wang, said, "We have confirmed that these appear to be packed with ancient stars, hundreds of millions of years old, in a universe that is only 600 million to 800 million years old. It was totally unexpected to find old stars in a very young universe. This is, without a doubt, the most peculiar and interesting set of objects I've seen in my career." So what's next? The team now plans to further investigate these puzzling red dots to gain a deeper understanding of their mysteries. They aim to conduct extended observations using the JWST to capture detailed emission spectra of various elements from these objects. Meanwhile, the James Webb Space Telescope has identified what might be the universe's earliest star clusters. The powerful telescope observed 5 protoglobular clusters, which are dense groups of millions of stars held together by gravity, within the cosmic Gems arc, a galaxy that formed merely 460 million years after the Big Bang. This galaxy, named for its visual resemblance to a hair-thin crescent, is the most highly magnified area observed from the universe's first 500 million years, providing astronomers with an unparalleled view of how the early stars shaped galaxies during the cosmic dawn. Within the cosmic Gems arc, astronomers identified 5 forming globular clusters, each about 3¼ light-years in diameter. These clusters may host some of the universe's first stars and provide fresh insights into the epoch of reionization, challenging our cosmic model. During the epoch of reionization, the universe was shrouded in neutral hydrogen, creating a cosmic fog that obscures our view of the very early universe. Eventually, this hydrogen got ionized, clearing the fog and marking the cosmic dawn, the closest observable event to the Big Bang. But what exactly happened that caused these hydrogen atoms to get ionized and thereby clearing the fog is still unknown. These globular clusters will help us understand that period, as they likely played a significant role in the transformation of the universe from the cosmic fog to the cosmic dawn. "The early universe is nothing like we expected," said Angela Adamo, an astronomer at Stockholm University. "Galaxies are more luminous. They form stars at breakneck speed, and they do so in massive and dense star clusters. We are building a new understanding of how early galaxies formed." To further investigate the early cosmos in this region, researchers plan to conduct a spectroscopic analysis with the JWST. This approach will allow astronomers to determine the physical properties of the clusters, refine their age estimates, and understand the influence these clusters' stars had on their surrounding galaxy. Astronomers currently estimate the age of the universe to be 13.8 billion years. And according to our models, the reionization era started approximately 375 million years after the Big Bang and likely concluded around a billion years after it, placing this galaxy in an era when reionization was in progress. This means that we're unlikely to find objects older than those within the cosmic Gens arc. However, with the Webb telescope, never say never. What do you guys have to say?